Question number 14. Marcus plays 2 games of tennis. For each game, the probability that Marcus wins is 0.35. Complete the probability tree diagram. So we know how this works. When you are winning, the probability of winning is 0.35. So the remaining probability, we know the total probability is always 1. Total probability is equal to 1. So if your winning probability is 0.35, if your winning probability is 0.35, then your losing probability should be 1 minus 0.35. So 1 minus 0.35, that's going to give you 0.65. So that's 0.65. So that's your losing probability. So we have to mark it in the branches over here. So Marcus wins 0.35. This is him winning. So Marcus does not win. That's going to be 0.65. So everywhere where Marcus wins should be the winning probability 0.35, and everywhere he does not win, you have to mark the losing probability 0.65. So I'll mark it here. Losing probability 0.65. Here Marcus wins 0.35. Losing probability 0.65. Winning 0.35. Losing probability 0.65. And they're saying in part B, work out the probability that Marcus wins at least one of the 2 games. So winning at least one of the 2 games. So at least one of the 2 games means at least means 1 or more. So you can win 1 or you can win more. More means obviously by more we mean both the games. So either you win minimum, you have to win 1 or you have to win both. So the first part, let's look at the first part in here. We can see in the first part, he wins the first game, Marcus wins the first game, and he wins the second game. So both the games he has won. So at least when you win at least one game, so we are okay with winning both. So the first part over here, yeah, so we are gonna take that probability we are going to consider. So how do you take the probability in the path? You have to multiply the probabilities along the branch, 0.35 into 0.35. The next branch that I have to consider, Marcus wins and he does not win. So in this branch also we can see he is winning one game and he is losing the second game. So winning at least one. So even winning one is enough. So then I have to take this probability as well. So in this case it's going to be 0.35 into 0.65. Then the next branch, the third branch, Marcus does not win the first game. He does not win the first game. But the second game he wins. So first game he doesn't win. Second game he wins. So he is winning one game. So that means I need this part, 0.65 into 0.35. Then the last part, Marcus does not win the first game and Marcus does not win the second game. So both games he is losing. And so this means I can't use this part in the for my part B, because I need to win Marcus to win at least one game. So I'm not going to take that part. So now what we do is the probabilities that we took, these probabilities, they need to be added. 0.35 into 0.65, that's the 0.35, that's the probability from the first part, plus 0.35 into 0.65, that's from the second part, plus 0.65 into 0.35, that's from the third part. So your answer is going to be 0.5775. So this is actually one way of getting this done. Or we even have a shorter method. There is another way. The other way is the second method. The second method of getting this sum done is we take the probability of the part which does not come into our question. So the part that does not come here is Marcus losing both the games. So what I'll do is the other method of getting this done is I'm going to take the probability of 1 minus probability of losing both the games. So this also is going to give me the same answer as above. So 1 minus probability of losing both the games is 0.65 into 0.65. So when you take this, you will see your answer is 0.5775. So whatever the way you go, both these methods are correct. So you can go with any method that you find easy. So the answer is 0.5775.